Yep.
Okay.
Hey guys.
Hello.
I haven't watched the meeting from last week. Been a little busy this week. So
There
was no meeting.
There wasn't one last week?
So technically we met, but we really didn't have much to go over, so we kind of just bullshitted with Josh and then called it.
You guys didn't review the chapters you read at all?
I mean, so some of us only got through one chapter.
Yeah.
Yeah, like me.
I had difficulty getting through the first chapter, to be honest.
And we just figured, why not just hold it off and review chapter today?
Okay.
It just seemed like a better plan since not everybody was there anyways.
Yep.
Okay.
And then it also gave Josh time to read the chapter if he shows up.
Oh, so Josh was there last week?
Yeah.
Yeah, for a little bit.
That's good.
He'll also be here this week at the end of the meeting.
So
That's not great.
I wrote some notes and then I accidentally went ahead and put stuff on top of it, so that's no good. But I can read it for the most part. I went ahead and wrote down notes as far as the different resistance band callers and what they mean and everything, that for just for memory purposes. How to read voltage versus resistance and all of it. So no, I feel like it was pretty helpful. It's just one of those where I'm literally going to have to go back and just re-reference it again and again and again until I just kind of.
Well, you got to remember something. This is not stuff you want. You don't want to memorize. I mean, some of this stuff you're going to memorize, but a lot of it's reference anyway. So all you're doing is, as long as you have an understanding, a basic understanding of everything.
Yeah. I was looking at it more from the angle of, I have learned this before and then I forgot it, and now I would just really like to just really get it in there to where it's like it's not gonna whatever.
Well, I can also put it this way: the only reason that you would ever need to know this knowledge is if you're going back for your A+ license or something along that line.
Why would you go back for an A? Well, hold on, you wouldn't need.
No, I don't think you need it. I don't think you need to really know much of it for
A+, or a different A+ license.
This is what all you're going to do is have some fun.
Trying.
I know it's either A++ or C++ where you need to have some of that knowledge.
A+
this is what I deal with 24/7. Just saying.
Well, A+ is specifically for break fixing computers.
You're right.
I think it's probably A, but I don't think it's. I don't know. I'd have to actually look it up.
Okay, getting off topic. So, did you guys want to discuss the actual chapter at all, or what do you want to do?
So the first chapter is more or less just pre-testing material. Like, a lot of the stuff I wrote down was how to remember V equals IR.
Yep.
You know, how to go ahead and convert that, converting power, what you typically discuss as far as, like, okay, power is typically watts, voltage is typically, volts, current's typically amps, resistance is typically...
Well, I thought Leon was going to make a test. Did he not do that?
So we haven't. So we haven't because the pre-test is already there. You're already taking a test in the chapter. So I didn't want to mess with that. I think we're going to do the...
She said we need to have fun.
Yeah, she did. She's trying to, like, play with my stick a little bit. Anyways, so basically, I'm not going to do the
or
what's that?
Nothing. Go ahead, buddy.
So basically, what I'm going to do is I'm going to do the test after we do all the chapters. Okay. I think, or maybe a midways test to just see how everybody's retaining everything. I think that would be the best bet because the first two, just about every one of these chapters has quizzing through it.
Yeah.
So if you want to, we can go over the questions in the chapter if you want to.
Yeah, let's go to no. Okay.
Most of it's just algebra personally, but yeah, we can go over it if you want.
Yeah, that was the fun part.
Yeah, the fun part.
It kind of was until I started going, none of this matches any of the diagrams that I have, and I'm not sure how you got this answer because you're not showing your work. That was the biggest problem I had.
The answers are easy. If you just pull up a calculator, punch it in real fast, said and done.
No, so like...
Problem is you need to understand the math, not just with calculator.
Well,
the math bind is easy. It's just like when they start putting in like decimals and shit, I'm like, nope, calculator time.
No. It was easy enough for me to figure out until they had the final test in the chapter where they started referencing diagrams, and I'm like, well, I don't know what the equation would be for this. This doesn't match anything. That's where I started getting confused.
Are you talking about like the parallel versus...
Okay, so stop. Give us an example. That's a better way to do it.
Let me
give us an example of what you're doing.
Yeah, let me bring up the actual chapter here real quick.
Yeah, everybody, if you got the book on hand, go ahead and bring it up real quick. That way we can reference it.
I'm trying.
I didn't download it on this computer, so give me just a second.
Here we go.
It's in my bookmark somewhere.
Let's see. Okay, so when they do the actual DC pretest, which is on like page 43 toward the bottom of it.
Okay, hold on just a second, Eric, if you don't mind.
Sure.
I got to pull up the book real quick.
Okay.
Oh, I got to remember the book name. That's the hardest part.
I've got to say
complete electronic self-teaching guide and with projects.
Yep.
Yeah, I've got it right here. Thank you.
It was more for me.
See, I've got that, the Linux book, and then the new bundle of books that I haven't actually categorized yet, and that's literally the only things I've downloaded. That's the reason I was just able to pull it right up.
This thing's taking forever to load.
Actually, if you want, I can just share my screen real quick.
Yeah, that's fine. Go ahead and do that.
Yeah, that might be a little bit easier. There we go.
Yeah, I think... here we go. Nope, I found it. Here we go.
I've got them here. I just can't remember where I put them.
It's at page 43.
Okay. So, this is where I was getting confused because it kind of looks like one of the earlier circuits that they're referencing. But I didn't understand, for example, like, okay, what's this V1, V2? Because, like...
That's voltage. That's two different voltage.
One voltage, too.
Yep.
Well, right. But what I'm saying is, okay, should I only be paying attention to this part and not this part? Because that would kind of match what I already had written down for, like, a previous section there.
Well, yeah, you're basically trying to find R and I so that way you can solve... Hold on.
For V.
Well, the reason I'm asking... Okay, so let me bring it back here.
Oh, okay. I thought that was something important.
Okay,
it wasn't.
So for example, that kind of matches this diagram, which was the original diagram where it asks you to go ahead and get, the total amount of voltage there, which I understood. I was able to understand this pretty well because it breaks it down really super simple. But then later in the chapter, whenever they're like, okay, well, what about this? I'm like, is that an entirely new circuit? The same circuit? Like, what am I looking at here? That's the reason why I was getting confused, because if it's the same circuit, but they just, they're saying, oh, well, it's going to be whatever. Okay, I guess. I don't know. It was throwing me because this didn't look exactly like the same circuit, so I was like, I don't know what you're having me try to do here.
So Eric, that's the idea. So this right here is showing you have multiple voltages. So V1 is going to be different than V2. The VS, that's the total of V1 and V2.
Right. Basically, because what it originally had was VO equals VS times R2 over R1 plus R2. And I understood that. I was able to actually convert that really easily. But I didn't understand if, like, I don't know. I was getting kind of confused because that was not in the original example. So I was like, well, then I don't understand, like, how I'm going to convert exactly for that. Ooh. So that's the reason why, because what I would do is if I really didn't understand, like, how to get the answer, then I would kind of skip forward and go, well, okay, what's the answer? Okay, let's see if I can kind of go backwards and figure out how they got that answer. And I was like, I don't know what math you used to get there. Like, I'm looking through my notes and everything, and I have no idea what you did here. So, yeah, I don't know. It was stuff like this that was starting to throw me in the pretest, because I was like, all right, well, screw it, I'll go ahead and skip it. What about this one? I'm like, that doesn't look like anything I saw. Great! This is going to keep on being a trend, and that was kind of the problem. Like, I understood the chapter.
So hold on a minute. So, like, give a problem that's an actual issue.
So, I know for the first question there, you're looking for, like, RT, correct?
Yeah, you're looking for RT and I.
Yeah.
So you're looking for...
First, you'd find the formula to equal R.
Yep.
And then you would dissect the diagram to make it so that way it equals out to RT.
Okay.
So RT is
going to be the equal of both resistors.
Right. So exactly, it's a total resistance.
Okay.
Yep.
And then I is impedance. So it's it's what is impedance?
Current.
V equals IR. So impedance is So, so in order to solve I here,
is
you
that
would take
what I stands
R,
for? Because I mean, it said current, so I was like, I don't understand why it's called
difference.
I.
Yeah.
It's the same
okay.
difference.
No, I know it's the same thing, but I never understood why they called it I.
So if you're trying to get R here, you would do. So you're taking I by VS. Or you're not multiplying them. I think you're. Is it division for that one?
For which one?
In order to get total resistance, it's going to be. Isn't it I divided by V?
Hang on. I thought I wrote it down, but maybe I didn't.
Total resistance is going to be. No, total resistance is R plus R1. That's total resistance.
Well, you're correct, but it's already given you the answer, basically. Well, is it? Yeah, it gives you the total already. R1 and R2 is already there in the equals.
So that's 48 ohms, so it should.
So you just add.
Hang on.
So you're just adding the two together to get
I'm
R.
just making sure.
Correct.
Okay.
Okay, so it is 48 ohms.
48 ohms, and then the resistance, which is your amperage.
Mm-hmm.
I was trying to do it the harder way.
That would be your ohms divided by voltage.
Oh, you're right, because it's 48 divided by... No, it's voltage divided by resistance.
Yeah, do it backwards. Yeah, I always get it backwards.
You're right, because it is 0.5.
Correct.
Okay.
Well, see, I was looking at the diagram because I know, like, you can always get V by timesing V by timesing I by R. So I was trying to do
the other reason this was confusing for me is because, again, I'm trying to like do it backwards because I'm like, okay, I kind of understand how you got this, but yeah.
My problem was I was looking at RT and not realizing they were giving us R1 and R2. I didn't even put the two pieces together. I was trying to do a whole different math.
Slow down and read the entire question, right?
Let me see.
Not being a smart ass, I was making a comment.
Oh, no, absolutely.
I saw Darnell's look there.
It's okay, you're not being a smart ass. Everything's fine.
I still would have got the answer my way. It just would have took longer.
Let's see.
The thing is, that's don't overthink these problems. This is simple math, guys.
I know.
It really is.
I do have
take your time and read the question. So, like, just like this, any of these here to find out what you're looking for, you only need two variables to find any one variable, right? Mm-hmm. So if you have 120 volts and you know you have 12 amps, what's the resistance on it?
Hang on. So this should be 6. This should be...
Or don't answer
18.
my question that I just said.
No, I was doing the math in my head. I'm sorry. So this should be 6 and this should be 18. Let me check to make sure that's right. Nope. I was wrong. 5 and 15. How the fuck?
So much scrolling.
Oh, because they changed it around on me. Okay.
Yeah, they put in different variables.
I thought they were basing it off of this one, so okay. Okay. No, that's
so. Let me ask you this: I can't remember. Did they cover wire size in this chapter? They didn't.
No.
Have they? Okay. So I'm not going to go into circular mills.
Okay, I'm going to go ahead. I'm going to jump out of this because actually, now that I understand this is not a brand new circuit, it's just saying, hey, the voltage between here and here, it's the same circuit. Yeah, I should be able to figure that out now. Okay.
Okay.
Yep, I just need to write down all the formulas. That's all I need to do.
So, give me a minute, or not a minute, but before next week, I'll get you guys a copy of the NEC. It has all of the actual electrical formulas and how to figure out for like wire gauges and like your solder points and all that shit. So I'll send you guys all a copy of that too. I have a copy from work.
Sounds good.
So you're just sitting there nice and quietly, Darnell. You got any questions or anything?
No, I was just reviewing the equations. That's
okay.
all.
I didn't.
That's the main thing.
You said you got a chance to go through the first chapter, right?
Yeah.
Okay.
So what did you get out of it?
Honestly, I spent most of my time just familiarizing myself with what each variable means and then what equations to use. This was a lot for me. This was the first time I've ever gone through anything like this. So it was kind of like shooting a water hose at a teacup. So I'm actually going to probably end up going back through it like a couple of times. But
you're going to
not familiar with the actual variables and just some of the formulas so that I could figure out most of the chapter. But going through the entire chapter was like kind of like trying to walk through mud.
So when I went through school, like from 2005 to 2007, they literally told us, they're like, write these down because if you don't have them during a test, you're gonna be fucked.
Yeah. I mean, but now I mean, just like you said, this is a lot like algebra class. It's plugging the variable, figuring out the formula. It's just getting used to the terms is the only part I'm really kind of struggling with. And then if I don't understand the terms, then trying to calculate the formulas gets kind of hard.
Yeah.
Oh, dude, every person.
Everything else seemed pretty clear cut.
Dude, every person that was in my CNET class that also had algebra with me, like the teacher was like, "You guys all get this real well." I was like, "It's nothing compared to the formulas we do in class."
But yeah, I mean, honestly, just remembering that voltage is equal to the amps
IR
distance. Well, yeah,
that's just VIR. Yep.
Yeah, it's just you can just say IR, but yeah. But yeah, it's just that's pretty much the only thing that's kind of carrying me through.
Yeah.
So get out of the habit. So
get it down.
So make sure you get out of the habit of just going IR. That's the thing. So use the full words, because I know, like me and you, Matt, are going to know what that means.
Yeah.
But Darnell's not. I'm not saying you don't, but at the moment he doesn't.
They'll hit them with other. Yeah, I know what you mean. They're going to use other terminology.
With the terms. So I have been saying IR. I've been actually saying them so that I can understand. I make sure I remember what each one of them is. And once I have I'll use it.
That's something we should look into as well as terminology. Make sure we understand all terminology. Because I know if you go to any place, it doesn't matter what you're working on, any work site or whatever, all the nomenclature is going to be the same, because it has to be the same, because it's a national electric code. There's a reason for it. So that we all have to be on the same page. So just it's cool. So
what I usually do to help me remember especially advanced concepts is I'll come up with like a fun way to remember it. So a lot of people, like if they're studying for like Network Plus, if they want to remember the 7 layers of the OSI ISO model, which is just how networking works basically, they'll remember something stupid like please do not throw sausage pizza away, or all people seem to do data processing, which is just the different 7 layers of it. So what I can do here is I can just say, VER and then IVR RVI. Because if I remember VER first and then, IVR RVI, literally VER is the normal version, which is V equals IR, versus I divided by VR, or, I equals V divided by R, and then R equals V divided by I. Basically, if I can just kind of train that into my brain over and over and over again, it'll be easy enough for me to remember it, because I'll go, okay, wait, why am I remembering? Oh, because it's this. Like kind of one of those types of deals. You just kind of connect it here and there. A little bit of mind mapping, basically. And I can go through what all people seem to need data processing is if you're really, really interested as far as Network Plus, but it's not super relevant to what we're doing right now.
Yep. So we're speaking of these. I don't even know what the mnemonic things
are called. Yeah, mnemonics or something.
Phononic or whatever it is. So do you guys know how to do the resistor one?
Resistor.
Yeah, how to remember a resistor.
So what I wrote down, and as I started writing it down, it made a little more sense. You got black, brown, and then rainbow, and then gray, white, gold, silver.
Wait, what are we discussing exactly about the resistor?
The colors of the resistance bands.
So the colors equal out.
Okay, the color coding. Okay,
right.
Thank you.
So you got black, brown, red, orange, yellow, green, blue, violet, gray, and white.
Yep.
So the way we learned it back in school, like back in when I took my stuff, it was bright boys rave over young girls, but Vito getting wed. So that's how you remember it. I know it sounds silly, but it's something everyone learns, and you remember that. You remember what the colors are.
It's how Google translated what you said.
What?
Well, it threw in a couple of other words there, and definitely threw in wet at the end.
Well,
nice. Okay.
So I'm going to remember it as black, brown, rainbow, because that's just, I don't know.
Yeah,
white rainbow. It's red.
Black, brown, Roy G. Biv, absolutely.
Yep. So, but you're leaving out other colors is the issue.
Yeah, gray, white, gold, silver.
Well, right.
Yep.
You got the gray, white, and then you're done with the main stuff, and then gold and silver is typically used for.
Gold and silver is tolerances.
Yes.
That's it. That's a 5% or a 10% tolerance.
Mm-hmm.
So you have to. So the main colors you need to remember are those 5. That's it. That gives you your number value, and then you go from there.
Mm-hmm. Yeah,
and really the tolerances aren't really as important until you get into fine electronics, like what we were dealing with the Arduinos, because you can only have a variance of like so many percent. Now on big electronics or actual electricity, you can have your variance is like a full. So like your 120 that comes out of the wall, it actually varies from 118 all the way up to 125.
Okay.
So if it goes any higher than that, that's called a swell. If it goes any lower than that, then that's called a dip. And that basically says that there's something wrong with your leg of your transformer or whatever is at the house or your apartment complex. So that's how they figure that out. And the resistors for those are actually in your transformer, and those are some big ass resistors too.
Oh yeah.
I mean, they're fucking like the size of my forearm. So that's getting off topic. But anyway,
okay.
Sorry.
No, this is all interesting stuff to me, so it's all good.
One other thing I'd say, probably the easiest subject in that entire chapter was probably switches. I'm sure you all got that pretty easily.
Yep.
Yeah.
Okay.
Open, closed.
I figured.
Yeah. Yep.
Darnell?
Yeah.
Okay, I'm sorry, I didn't hear you.
No problem. Yeah. As we're talking, I'm listening on one end, but I'm also going through some of the chapters. Basically, every time we switch topics, I just got to fly through that area so that I can also just keep up with it.
Yeah, that's cool.
But yeah, I'm completely paying attention. I'm just following along.
Okay. Yeah, we're all kind of a hot mess when it comes down to this. So I think we need to start working on kind of an agenda as we do the meeting. Let me look here. What was the name of the book again? So I have it. Sorry.
Okay.
Complete Electronic Self-Teaching Guide with Projects.
Yep.
Thank you.
You go away from
Sweet. Yeah, I got it right here.
Oh, shit.
There we go. Okay. So let me go through here. I want to see this. Delete two. So we got current flow. Everybody understands current flow, right?
Yes.
Yeah.
Okay. So, Darnell, explain.
Okay, so there's understand.
So just give me a simple definition of what you understand it.
Okay, so the current is the voltage divided by resistance.
Stop. Nope.
Okay.
Not what I'm saying.
So
What
the
is
flow
current?
goes from when voltage enters to the ground.
So what is current? That's what I'm asking. I don't care about formula.
No, I'm not going through the formula. Basically,
Right. What is current?
like if you have a battery hooked up, it's going around from the positive to the minus.
which is what?
Flow.
That's what I'm asking. It's the flow of
electric charge.
Thank you.
Flow of electrons. Yeah.
Flow of electrons.
Yep.
Okay.
1 second. I'll hear you guys. I just got clean.
So I think we should go basic, right? So, like, literally, what's the definition of it? If you read this, you should have somewhat of a definition, even if it's just in your own words, right? So yes, it's a flow. The actual definition in the book is the electric current is the flow of electric charge. The electric charge usually consists of negatively charged electrons. However, in semiconductors, there are also positive charge carriers called holes. We'll get into that later on, and I'll explain to you guys if you guys don't understand those. That's called a reverse positive. Like our vehicles, a lot of our vehicles run on reverse positive. So, like your lights turn on when the flow is backwards, basically.
Yeah. So
instead of having normal flow, it actually kicks on on the backflow, the absence of the flow is what it does. So let me look here. Go down the answers here. Well, Matt's there. What's Ohm's law?
Ah, crap. I don't remember the exact thing for Ohm's law.
This one actually is an equation. Ohm's law.
Oh, Ohm's law?
Yep. What is it? Without looking.
Isn't it the V equals IR?
Yep.
Yeah.
Oh, okay.
Yeah. V equals I times R.
Okay.
So that one is this is the most basic equation in the electricity, and you should know it well. In other words, this one you should memorize. Some electronic books state Ohm's law as E equals IR.
Yep.
So that is still times, because if in an equation we know that a constant next to another constant is an actual multiplication, right?
Yep, correct.
It's just assumed. E and V are both symbols for voltage.
Mm-hmm.
Correct. So one's electrons and one's voltage.
Right.
Yep.
This book uses V to indicate voltage. When V is used after a number in equations and circuit diagrams, it represents volts and the unit of measured voltage. Also in this formula, resistance is the opposition to current flow. Large resistance results in smaller current for any given voltage.
Mm-hmm.
Right? So if we add a resistor, we're going to drop voltage, right? Simple as that.
Yep.
Okay, so we understand Ohm's law. We just keep on rolling. What's a resistor?
Well, just what you said. It drops the overall.
It's the resistance of voltage.
Mm-hmm.
Okay. So what could be used? What's normally used as a resistor? You guys know?
I didn't hear what you said.
What's usually used for a resistor? What's it made of?
Ceramic.
Oh, yeah, ceramics.
Yep. And why is that?
Good insulator.
And so if it's an insulator, what does it do?
It drops the voltage. If it's a pure insulator, rubber, plastics, different stuff like that, it can completely cancel it out in some cases.
So you're right, but what else can a resistor help with?
Oh, I'm not sure. I'm not sure where you're going here with.
So if you touch a resistor and it's have voltage on it, what's going to happen?
You could get shocked.
Not well. Yeah, only if you're grounded. So what should you feel on that resistor?
Heat, right?
If you're blocking voltage, making voltage build up.
Mm-hmm.
Yeah, it would be heat.
Yeah,
it builds heat.
Okay,
that's it. So in your ovens, for example, your resistor is your oven element, right? Your element is a resistor, essentially. So you follow?
Yeah.
Yeah. No, that makes makes sense.
Okay.
Yeah.
Just making sure. I'm just I know I'm covering like really basic stuff, so I want to make sure we're all on the same page. So
no, that's fine.
So that's literally what it is. So it works the same thing as your water heaters, your ovens, even your space heaters. Those little coils are resistors. It's just a different way of using them. Is all it is.
Okay.
Wait, the coils are the resistors?
I thought they were conductors.
Well, they're conductors, but that's exactly what a resistor is. It's
I know. I was going to say that, but I was like, Then you guys want a whole other thing with the heat. I was like, oh, you know what? Forget it.
Because that's so essentially those are made to
conduct and resist.
Exactly. It conducts all that heat or all that voltage, and it builds all that heat from the voltage just being resisted. That's all it is.
Yep. Okay. Where a capacitor would take it in and store it.
So I can show you a nice little example of that too next time you come over, Eric. So whenever if you ever pull off the top of a soldering iron, you have the thermocouple, that little the heat element, right?
Okay.
So if you watch it, it'll actually expand and contract. So when it expands, that's when it's heating up, and when it contracts, it comes back down, changing the type of resistance it's holding. So the hotter it is, the less resistance it's going to have. So it's going to be kind of useless, basically. Remember, that's what we were having issues with some of our resistors on the projects. So that's when they would burn out.
Yep, and the heat, basically, with it expanding, makes the tip coil hotter and colder, and so on and so forth.
That's where you crack the resistor itself.
Yep.
I mean, this is interesting to me because I don't know these things, so that's pretty cool.
Yeah. Okay, so do you guys understand the concept of parallel and series?
Yes.
Yep. Okay, so Darnell, what's series?
Oh shit! I thought you were gonna say what's parallel. Fuck me. No, I am not clear on series. I am clear on parallel.
Okay, hold on a minute. Before you answer with parallel, Eric, what's series?
Okay, so I'll tell you what series.
Give me an example.
Is a series of resistors just multiple resistors on the same line?
Hold on. So a series is like this.
Which means what?
Whereas a parallel is like this.
Okay,
wait.
Okay.
Speak in positive and negatives.
Positive and negatives. What do you mean?
So a series.
Thank you.
You want me to go ahead and answer it?
Yeah, go ahead, Matt.
Okay, a series is where you're adding them together. So you're adding the resistance together inside of a series.
So what's it going to look like? Positive and negative.
It'd be positive. Or, well, you're putting more resistance when you put them in a series.
Okay, battery. Positive, negative, right?
So it'd be positive, negative,
negative. Same thing. Back to back, right?
Back to back.
So your positive and negative, your negative flow is always going to be going this way.
It's just a straight line.
Yeah.
You follow?
So it's just going to be positive, negative, positive.
Exactly. Parallel is when I do this.
Right.
Yeah. When they're running in parallel with each other and running.
So that's how our most of our remotes, toys, and all that stuff is, right?
Yep.
So you have positive here, negative here. So whenever you do this and that device, you can take one battery, hook this end up to the other connector, and this end up to the other connector, and you can run that device off of one battery. That's the idea of series, or excuse me, parallel. Sorry.
Yep. Let's just say.
Follow?
Yeah, that makes sense.
Okay. Moving on. What is power? When is power collected or created? No, whatever.
Right.
So what is power? Do you
Watts.
know? Okay. So what is it?
Well,
I mean, power is usually just a form of heat.
It's voltage with resistance.
Thank you. That's it.
Yeah.
I'm sorry, voltage with current, rather.
Right. It's with resistance. That's how you get your wattage. So a resistor on 120 volts, if you put 120 volts or 12 volts, for instance, since that's what we're really working with in the majority of the time, we use 12 volts and we put in a 5 meg resistor. It's going to drop the voltage down by 15%. Okay. So that means we're going to drop down to around 9 volts. Okay. So your power in that circuit is going to be the 9 volts, right? Your wattage is going to be probably about 3 watts, if that. I think I have to do the math.
Well, what I have here is power is There's a couple of ways you can derive power.
Times current.
Yeah, voltage times current is power. You can also do power is current square times resistance, or power can also be voltage squared divided by resistance.
Right.
Okay.
You know, just more formulas.
Yeah.
Yeah, all about the formulas. Essentially, just remember it's that the resistance that causes that helps get you your power formula.
Yeah, exactly. You can't have a power formula without resistance.
Exactly. Okay, small currents. We ain't gonna go over that because that's just talking about we know, you guys know, microamperes.
Yep.
So whenever you have like a milliamp hour battery, right? So we have a 3.6 volt battery, which is a typical lithium battery, right? And it's going to be 3,000 amperes. So that's going to last how long? Do you know?
I'd have to do the math.
Let's do the math.
Okay, hold on. You do that. Let's see. All right. So you said... Oh, crap. I don't have the time formula on me.
You can actually say 3.7 volts because that's a typical... like, we're going with like an 18650 battery, a vape battery.
Okay.
So if I was to constantly vape, how long would that vape last?
Not counting that.
Not very, because it's matte.
Because that's the thing we're figuring out. So what you're wanting to try to find is you need to find out how many watts you can burn at a certain amount of time.
Yeah.
That's what you need to find out.
Some of this shit got burned off. Awesome.
So basically what you're figuring up is you're going to figure up your voltage versus your milliamp hours. So you divide the milliamp hours by the voltage. That's going to give you your max wattage.
Okay.
So at that max wattage, that'll tell you how long you're going to be able to burn that battery at, say, 80 watts. Okay? So the less you burn it, so say we burn it at 40 watts instead of 80, that means you're going to get double the time that milliamp hour would at max voltage or max wattage. That's the reason, like, especially when vaping, like if you guys have ever dealt with that before, they always tend to tell you to stay that this battery is a max voltage or wattage of 100 watts. If you go over that, you risk the chance of blowing up your battery because basically the resistance on that battery is too high and it's getting too hot. And it's going to blow. And that goes with resistors, capacitors, all that bull crap.
And Samsung Galaxy G5s.
And, well, I think S7s, I think. But yes.
Oh, yeah.
Okay, we ain't going to worry about graphing resistance. We know how to do that, right, guys? I mean, essentially, it's the algebra.
Just calculating slope.
Yeah, that's it.
I wasn't even looking at the right fucking thing. Okay.
So I'm going through. I'm just going through and kind of reviewing these things here. Okay, what we know what a breadboard is, obviously, right?
Oh,
I hope.
Definitely.
What's blue stand for?
Positive.
No.
Negative.
Wait.
Blue's your grounding.
I mean, if you want it to be.
No, it's
Jesus, Matt.
the real thing.
Hold on.
Eli can't get in.
Eli's trying to join.
Tell him to.
Hang on.
So
I mean, honestly, if you're being dyslexic, you can set it up any way you want.
Yes, you can, but no, the way we're going to... Excuse me. Jesus Christ.
You're good.
The way we're going to typically do this
He doesn't have a calendar invite because he never gave an email.
Oh, tell him to give an email and I'll add him to the calendar real quick.
Well, you know.
That's the reason you join.
It's Eli. I don't know if it's the correct meeting. I just went ahead and truncated the little list up here.
Yeah, it's always going to be the same. But
Leon's
thing.
right. Red is always positive in.
Yeah.
Yes, I know that.
Yep.
That's the reason I said it.
I know. Blue will always... It'll be blue or black for your ground.
Eric, text him and ask him for his email real quick.
I mean, you can just throw it in the thread since it's just us. It's whatever.
Well, I know. But did you ask him, though?
That's a no.
There. Okay.
Well, you should specify Gmail,
right? It honestly doesn't matter, but yes. Oh, shit. All right, give me a second. Let me pull another one up.
Also, put your list of skills on here. Joining the meetings late.
Yep.
Be like, what are you, Rick? Did you get caught on the phones?
I think almost everyone's hit that achievement, though.
Right.
I know you have. I think me and Leon's the only ones that haven't.
Have I joined a meeting late?
The very first one.
Did I join after 8, though?
Yeah, dude, it was like 8:15. You're like, oh, I didn't know we were doing it now.
Yeah,
go back and have a look.
Of course, he's not going to add it in there.
Why would he?
I'm not going to waste any more time with it. All right, so let's see here. Okay, so on a breadboard, what rails hold voltage? Horizontal or vertical?
Yes.
Vertical.
Good.
I'm sorry, horizontal. Sorry. Thank you.
It depends on how you're looking at it.
Are you holding it like this or like this, Leon?
So, fair enough. A, B, C, D, and E are all facing to your left.
Okay.
So, which ones are they?
I'm gonna bring.
It's not hard. Think about it.
I'm gonna bring up the book. Let's have a look.
So it's the ones with the numbers.
Yes, that's correct. So, which ones are those? The horizontal or the vertical?
If we're looking at the same picture, vertical.
With A facing left, it would be horizontal, actually. But yes,
well, the problem is like A can face left or right. That's why I'm like,
well, how can it face left or right?
Because it labels it on both sides.
Yeah. So the mini breadboard in the book.
Yeah, based on the art book, based on the art in the book.
I'm looking at the book. It's like it's facing left and right, but okay.
No, guys, setting up. A is always going to be on this side, so your A row is on the left.
So if you scroll down, scroll down to the next picture. It literally does it the opposite.
Yeah, it does. It really does.
It does.
What?
Yeah, they do. They do. They fucked it.
That's fine. No, if you do it vertically, it's still on the left, guys. Look at it.
Well, but then you're
Leon.
If you're setting it on its ass and A is pointing upward, like you read it from left to right, it's always going to be on your left. It's like a chessboard, guy.
Hold on.
Correct. But the way they have this picture labeled, it's literally upside down.
Right. It is.
Okay. Whatever. Jesus Christ, you guys! I swear.
No, we're going off the book.
We're gonna say vertical, yes.
Yes, it is. It's actually the horizontal. If you have the board setting straight up with the A on this side.
Okay.
Okay.
Yeah.
So it's the horizontals. So line 1, 2, 3. Those all have concurring voltage.
Why did they put that picture so ass backwards? That's
you guys are thinking.
No, it was just funny.
Anyway, okay.
I know what they did. They did one that.
No, it's like I scroll up to the picture you're looking at. I'm like, makes complete sense. I scroll down to my picture. I'm like, why?
We all know how to use a multimeter, right? For the most part.
I haven't used one, so no, I really don't.
Yeah, I'm about to say I don't think I've used a multimeter.
Do you have one?
I have no idea right now. So I think I got one with my soda. I think it's packed up.
Okay. Let me know if you have any issues using it or whatever. Let me know. I can show you how to use them. I've got like 4. So if anybody needs one, you can have one.
Another great way to learn is just to play with it.
That's it.
Yeah, I'll probably just play with it.
Just be smart and don't touch. Don't use. Don't
electrocute myself.
No, well that too.
I mean,
don't use.
Don't reverse it.
Not reverse. You can reverse it. Oh, Matt. Continuity. Do not use continuity on voltage.
Okay.
Oh yeah.
So if you do that, you will short out your meter in a heartbeat because basically what you're doing is you're closing the circuit. So remember that, okay?
I was just gonna say, don't be Matt and lick circuit breakers, but okay.
That too.
I don't lick circuit breakers. I touch diodes and they blow up.
Yeah, I know.
Okay, switches. So what's a binary switch?
On or off.
Okay.
Basically open or closed.
Good. So what is a single pole switch?
With that, it's either 1 or 2. Basically, it doesn't really have a middle, per se. Both sections have a function of their own. So, for example, you could switch it to, let's go ahead and do this traffic lane on. Let's go ahead and do this traffic lane on. Kind of
absolutely.
One of those.
But for the most part, whenever you're using these, it's like a light switch. It's still an I and O, so it's still an on and off. Majority of the time,
it's a 1 or a 0.
Right, exactly. So normally, whenever you're seeing these in like industrial ideas, you're seeing a single pole used on a safety stop.
Yep.
So when it's open, you have free use of the machine. When you hit it, there's no use to the entire machine. So you got it's still a single throw. What's a double throw?
I think you have to let him in once he gets the link.
Okay.
Oh, okay.
Just let him know.
Wait, did he have to last time? That's weird.
Yeah, because he doesn't have the official invite. So when other people try to join that haven't joined, but that don't have a purpose invite, they have to be allowed access.
And he's still not sending the damn email. I don't know why he doesn't do it.
I'll just show him when he gets in.
So go here. Capacitors.
Yep, capacitors are they're fun.
They store
stuff. What are they?
Basically, ceramics. They're ceramics that store energy. I can't remember the definition. Or charge, whatever.
Right. So essentially, it's a battery, right?
Yep.
Okay.
And that has a certain time that it releases the charge.
Right.
Best way to think about it is like a flash, one of those old style like flash cameras where you would hold down the thing and then and it would go ahead and like. Yeah.
So essentially, that's the thing. That's the difference between a battery and a capacitor. A battery is a direct one-shot use for the most part. So it'll shoot all voltage at one time, and that's it.
Yeah.
With a battery, it will let it drain and trickle at a certain percentage, right? So it's stuck like 10 amps or whatever.
Best way to think about it is almost like instead of a sprinkler, it's like one of those super soakers. You got to go ahead and pump it up, and then when you're ready, you go ahead and release it rather than it just being a continuous stream.
Absolutely.
Yeah.
Eli, you on?
Please.
Dude, you're breaking up.
Is this better?
A little.
Yeah. Where's your video?
Bro. Killing me.
He's in the bathroom.
Look, I'm frantically trying to get my shit together here. One moment, please.
He's not even dressed.
Why don't you do me a favor real quick and you tell me your email so I can add you to the actual invite?
No, don't do that. Just go ahead and put it in the thread there. That way I don't have to edit more shit.
No. That's what I'm saying. In the Discord IoT thread.
Yeah, that's probably better.
Who's in the background there?
That is my buddy Dan.
Oh. Hi, Dan. Oh, I met Dan, didn't I?
You have met Dan.
Okay.
Not quite the one I wanted, but that'll work.
Eli, now you should just be able to join in without having to be accepted. I just sent you the invite.
Okay.
Okay.
Cool.
So we got that. So basically, we're going over the chapter where we kind of went through majority of it. We're just doing chapter 1 right now.
That's going over the basics. Right there.
Yeah, I think it is.
Literally, the last thing is the test.
Yep.
Okay, good. So, and we aren't going over the test because we literally just basically did our test anyways.
Yeah. Besides storing the basic knowledge and putting it to use, which we'll do down the line, we've covered everything.
Yeah.
Yeah, from what I saw in the first chapter, it didn't seem to be that complicated, but the future stuff looks like it might be.
Oh yeah, we're getting there.
Yep.
It's not too bad. It's just all about the just take your time and read it.
Yep.
As we've learned already.
And yeah, hey dude, I read. I just want to make it complicated.
So next week, so are we all going to have?
I said we just do one chapter.
No, that's fine. Are we going to have chapter 2 read next week?
Yeah, absolutely.
Yeah.
Like I told you, I already read through most of it. I will go through it again.
All right. So chapter 2 covers over diodes.
Mm-hmm. Mostly just diodes, if I remember correctly.
Yeah, I think that's all it is. So, what are diodes? Anybody know?
I've used them before, but no, I can't. I
can tell
I can't give you a description of them, but I mean, they're electrical.
You guys need to read. You guys need to make sure you read the chapter, because if you can't give me some kind of description, then you need to learn.
It gives resistance on an electrical current, but I am not sure in exactly what way it's doing this.
So it uses basically
an anode and a cathode to
the main characteristic
charges.
of a diode is that it conducts electricity in one direction only. So historically, the first vacuum tube was a diode. It was known as a rectifier.
Mm-hmm.
Right. So here's the thing: a resistor. It doesn't matter how you put it in the circuit; it's going to flow either way. It doesn't matter. With a diode, it's like a check valve. So it goes one way. Voltage can't go this way. All right.
So anytime you have to remember it, just think of a LED. It's the same fucking thing.
Yep. You have light LEDs, and then you have non-lighted LEDs. Simple as that. And you have IR LEDs, the whole bit. Those are all diodes. I think they're all covered in this as well. And it describes what they use, because all it is just the frequency of the voltage. That's how you get the light or whatever. So it basically uses the energy that it's taken in and does something with it.
Correct.
Yeah,
this chapter is actually really straightforward. Also,
yep. Let me see. I want to look at chapter 3 real quick, and it's transistors. Let's cover 2 chapters for this, because chapter 2 is transistors as well. Essentially, they're the same. They're kind of similar to diodes. They just have an extra leg, and you'll find out what that is. You guys think?
I didn't realize I was in chapter 3 already. Okay, yeah, I'm good.
Guys, I mean, I want to make sure you guys are all on board and comfortable with that as well.
I know I can do 1 chapter. I could probably do 2 chapters. I'm not 100% certain.
Leon, we can set it up.
I can promise 1 chapter for now.
Okay, that's fine.
We'll set up as 1. If we do cover more, we'll cover more.
Yep. Maybe if we go, because I think diodes are going to be a little short chapter. Maybe we can kind of go over chapter 3 as we do it just together.
Yeah. Since I'm already on the book anyway, let me because I thought it actually had a thing on here where it would tell me how long each chapter was. Could have sworn.
You mean page-wise?
Yeah.
Well, yeah, it does. It has an index.
Yeah.
No, I thought it had something on the left for it. Maybe.
No, it has an index in the very front of the book that tells you how long each chapter is.
Yeah, I just want to see, because if it's not super.
Chapter 2 goes to page 87 from 48. So you're looking at about 39 pages.
Okay. Then we'll just leave it at 1 week.
Yeah, I was going to say, because
that's a lot of pages to cover.
The first chapter was almost 50 pages, and to be fair, a lot of that was testing.
I will warn you.
Second chapter is 40-something. So
as we go further, the chapters get longer.
Yeah,
that's fine.
Like,
dude,
this one is like 80.
I plan on going back and reviewing chapter 1 anyway.
Yeah, we can literally figure it out as we go on. I'm not super worried about it. It's just
okay.
I mean, I was just see if it was one of those things where it was like, holy fuck, that's going to take a long time to go through, or oh, that really is a short chapter. You know, one of those kind of deals.
Okay, so I'm going to look through this too, just so you guys know. I'm going to. We have how many breadboards do we have down there? Do you know?
A decent amount.
Okay, so what I'm going to do is I'm going to set up some breadboards.
Oh
with
shit! A
pretty
lot of
much
this is Q&A on here too. Okay.
Yeah, it is. That's why I was saying about it being a short chapter. If you guys want to, maybe we can meet up sometime in the next week or so.
Yeah.
And I can divvy out everybody the breadboards, have them all set up for all these fucking projects that are in this, because they all basically take base on one breadboard. And we can all kind of, if you need to kind of understand how it physically works, we can just do that. How's that sound?
That's fine.
Works.
I know I won't be doing anything.
I'm also going to test out this.
It'll be next week.
What?
Oh, I got stuff going on this weekend, like from Friday on.
I'm not sure. What's that have anything to do with?
You said setting stuff up within the next week, so I was like setting up the expectation.
No, within the next couple weeks. I just whenever you guys want to meet up somewhere, maybe we can just stop and like say hey to each other, and we can drop them off, or something. Because I know Eric said might be coming over this weekend and help me with the shed. So maybe we can start. Eric can get like that, and maybe you guys can meet up somewhere or whatever. So
okay, yep. I'm just gonna.
When are you guys doing the shed thing?
This weekend.
Yeah, but
I don't know this weekend. I have no due. I'm off Saturday and Sunday, so I'm going to start working on everything. I need to get more pallets so I can start getting the walls up and everything. But
I'm gonna say I don't think I can help this weekend, but probably next week.
Fine. Nobody even has to. I'm just it's just an offer. So
no, I already
fine. I would love to come do that on Sunday.
I already committed to you.
Well, I'll be doing it.
And then realized I actually have a meeting with my friend from kindergarten. We're finally going to meet after not seeing each other for 3 years.
Oh,
nice.
Okay.
So that's my plan this weekend. Considering we both work too much and now I got time on my hands, he's like, cool, come over.
Yeah.
So yeah, we'll did Darnell drop out?
Yeah, it just seems like he's split.
I don't know.
Okay.
His connection.
I think
he clicked the wrong button.
No, I think he had something to do, and I think we're getting off topic. Oh, he lost connectivity.
But yeah, I'm planning on doing it this weekend, Eli. So if you want to, whatever, I'm probably going to start it on Sunday, probably 10 or 11, and I'm going to be working on until probably dusk or so. It depends on how much I have, because I have to get more pallets and shit too. So. It just all depends on how far I can get with what I got.
Oh, so you said starting it on Sunday?
I know a lot of places we can steal pallets.
Saturday, okay. I'm actually in the process of starting on it now, so I've already got my foundation. I kind of reconfigure some of the pallets so I can actually start nailing them in place and getting them lined up properly. But yeah,
no worries.
Nice.
Yeah, I was gonna say if it was Sunday, maybe, but yeah, Saturday.
Yeah. So it's
Saturday's the day of the meetup.
Katie's already talking about she's like excited about this done. She said, "I figured this was going to be your man cave. Is this big enough for you?" I'm like, "How much bigger you want me to have it?"
I mean, unless you want me to put a projector screen in there, be able to fit the pop can in every corner.
Well, that's the plan. So, I've already figured I'm going to run a 50 amp service to it, and I'm going to have my TV in there. I'm going to have a place for my computer, obviously.
Oh yeah.
And then I'm going to have my forge, so I can start making knives again.
You going to do like an underground Cat 5 setup, so that way you can have Ethernet walls?
Yes, I plan to. I'm going to actually pull everything from the side of the corner of the house where the electric is, and my actual switch. I actually have the router.
Okay, that works.
Outside.
I get exactly what you're saying.
Yeah, and then I'm going to move a switch into the network, into the room there. So.
Yep, no worries. I was gonna say I helped network the entire Verizon building when I was there, so I get that.
Nice.
Yeah. I'm going to. I need to find. So I'm trying to do everything reclaim. So I'm trying to find everything I can without having to spend any money on it. Obviously, I'm going to have to I need plywood for the flooring. I was just going to do planks on the floor, but Katie's insistent on wanting to put plywood down, so I'm going to do plywood, and then I got to.
The minute that you have one gamer reach, that floor is going to go down.
No, it's not. I'm telling you right now, this place, I've already got everything planned, how it's going to set. I don't know if that's going to be my gaming shack, but I don't know. It could be. You never know.
Depends on how you feel.
Yep. So I've got some plans for a table that folds down off the wall, so I don't always have to have a table in the middle of the floor. Some other things. I need to get pegboards up and everything else. So it's got a big project, but hopefully we'll see how it works. So yeah, Eli, if you're interested, you're more than welcome to come over Sunday.
Yeah, sounds pretty fun.
Yeah, make sure you bring some liquor.
I will do my very best to bring some liquor.
Or beer.
He's gonna bring like licorice.
Licorice, yeah.
It's sort of liquor. It's licorice.
Yeah. I've got my Elijah Craig, which I might crack open, and then which it's already open, but it's like I haven't drank it since January. I've got a little bit of beer, and I got my bottles of vodka, so I might have a little bit more later. It just all depends.
Depends on how game night goes.
Yep, we got fire pit and everything in the backyard. So after we're done fucking around, we can have fire and toast marshmallows.
Awesome.
Yeah.
Or if you're Matt, put a bottle on the end of a stick, and why? Because he can.
What?
Oh, I've been so drunk where I forgot to put I had a marshmallow in one hand, a beer can on the other, and I put the beer can on the stick instead.
Sounds like a very Matt thing to do.
Mm-hmm.
Oh,
Later, just got pulled it out, and I was like, "Huh, so this is a little more canny than I thought."
Right.
Oh, and I'm going to say something too. Have you guys tried the Sour Patch Kids Crush?
No.
Oh,
nope.
I'm trying not to drink pop though. That's
I don't either very often, except for with my liquor. Yeah. But I had a cup of this stuff, and I swear to God, it's like screaming. It needs liquor in it. Like it's that good.
So it's probably like the equivalent of me. I know at the bar I used to order a thing called a Swedish fish, and it was a liquid Swedish fish.
Oh my God, it's so good, so good.
Oh, dude. So all I had to do was add some sweet and sour to it, and it'd probably be a red Sour Patch Kid.
Yep. So how's everything going over there, Eli?
Say again?
I said, how's everything going over there, buddy?
Doing all right. Still alive. Still employed.
I heard that you had a drive. He had a 2-hour drive last night. I know that.
Mm-hmm.
But then you left the call shortly after.
Yeah, well, I was helping my dad move shit into his apartment over there, and so it's a 2-hour drive up, 2-hour drive back, and he caught me as I was driving back, calling me on Facebook.
So Luis actually called. Did not know how to just select one person, apparently.
Oh.
That would be my only guess, because I did the original call, which I invited one person because I assumed everybody else was either busy or didn't want to play.
Mm-hmm.
And then the call drops, and I'm like, give me a second, dude. I gotta, lower all my stuff down, give you a call back. No, the guy just decides he's drunk enough to try to call us all.
Seems pretty normal.
Yeah.
So there's one chapter we may not even really be able to touch, just like I said before.
Why, what's
up?
The oscillators.
Mm-hmm. I noticed that one.
We can get a cheap one for $19 on Amazon, just saying. I'm looking.
We'll see what happens when we get there.
Wait, we didn't have one when we were messing around at Dish?
No, we didn't. No, we didn't. That's if we had that, me and Eric would have been able to find out how to use the deep sleep mode.
Oh no, I was talking about after you left. I swore there was a new project I came up with that needed one, but
an oscillator?
No, I don't think so.
I thought the LED matrix that you could wear we
never started working on that one, so I don't know.
Of your leg.
Yeah, that's kind of what the LED was supposed to do. Like when you put it on, it would turn on. When you took it off, it would automatically recognize that it was inactive and turn off.
I don't know, man.
An oscillator is the same thing. It's kind of similar to like a multimeter, is what I'm saying. So I don't see why it would be required for a project.
It wasn't a requirement as more as an optional feature.
Okay.
trust me, if I could dig up the schematic, like, remember how thick that fucking project was? It was like this.
Oh, yeah. It was real thick.
So, I mean, I guess that's pretty much it, isn't it, guys?
I think so.
For the most part.
What?
We were planning on leaving whenever you turned around.
Cool. Leave. Bye. See, what I should do is blow smoke in the camera and just leave.
Right, that's the way to go. Just be like, smoke bomb!
White out. Well, apparently Josh didn't feel like joining in today.
Seems that way. I think I might jump into a game here. I think the meeting's kind of over since Darnell lost connectivity.
Yep, I'm going to go ahead and cut it.